hydrographs are sometimes called storm hydrographs or flood hydrographs, and in the real world they can be quite complex graphs going on for a number of days and showing lots of periods of rainfall and the way that the river responds accordingly. For this exam you'd only need to understand a relatively straightforward hydrograph, so I'm just going to draw one now. Now, at one side of the hydrograph you would have an axis that was called something like rainfall, and that would be shown in millimetres. Now, I'm not going to put the axis label on because it doesn't really matter too much, but it might go up in 10, 20, 30, 40 in millimetres. And down the other side of the hydrograph you would have discharge. Now, discharge is the level of the river, the height of the river, or how much water's in there, and that's measured in cumex. Now, cumex stands for cubic metres of water per second, and then across the bottom of the hydrograph you've got time. And that time might be in hours, it might be 2, 4, 6, 8, 10 hours, so on. Now, if it rains, the rainfall is plotted according to this axis here. So I'm going to plot some rainfall onto this graph. Now, as it rains, often it starts off a little lighter rain and then it tends to rain a bit heavier and you get this sort of peak rainfall here, and then the rainfall might slow down a little bit, which is what we've got here. Now, after that happens, the river is going to change. So next thing I'm going to do is plot the river on here. Now, the river is plotted according to this side here, the discharge. So this is the volume of water that's in the river. Now, as it rains, the volume of water that's in the river is going to increase. The river's going to fill up, but it isn't going to fill up straight away. There's only a small bit of that water that actually falls directly into the river. The rest of the water falls on the landscape around. So it's going to take some time for the level of the river to actually increase and for the river to fill up. So you're not going to see it increase straight away. You're going to see something a bit like this. Now, sometime after the peak rainfall, the river starts to fill up. And then over time, as the rainfall stops and the river empties away into the sea or another river, it then slows down. Now, the other thing that you tend to find on a flood hydrograph is something called base flow. And base flow would be around about here. Now, base flow is the level of the river had it not rained. So the normal level of the river. Now, there's some bits that we need to be aware of on a flood hydrograph. This here is called peak rainfall. That's the time when the rainfall is the highest. This here is called peak discharge, and that's the time when the river is at its highest. Now, if we take the difference between peak rainfall and peak discharge, what you've got there is the lag time. It's the time taken for the rainfall to actually make its way into the river. Now, there's another video on lag times, so I don't want to talk too much about lag times, but lag times can vary quite considerably. And then the other things that you need to know about is that this bit here is called the rising limb, that's when the river rises, and this bit here is called the falling limb, and that's when the river falls. Hydrographs can be different shapes, so if the lag time for this particular river is very quick, if the rainfall enters the river really quickly, and again you can watch the video on lag times to find out why that might happen, not only will the river fill up more quickly, so it'll be further over this way, it will also probably be fuller, because that, rather than that rainwater all getting there slowly, it's got there in one go, and you might get a lag time that looks, you might get a hydrograph that looks a bit more like this. That hydrograph is more likely to flood. The rainwater has got to the river really quickly, and therefore the river probably can't cope with that volume of water. If you've got a really long lag time, then the river is most likely to respond a bit more like this. And that's the sort of river that you want, because it's going to be less likely to flood. Question 1. How can we see lag time on a hydrograph? Lag time is the time difference between the peak rainfall and the peak discharge. So if you look at the highest bar on the hydrograph for rainfall, and you look at the highest point for discharge, and you measure the time between the two, that would be your lag time. 2. What are the rising limb and the falling limbs? The rising limb shows the river filling up. So it's an increase in the discharge on the hydrograph, and a fall in limb shows the river emptying, and that's the downward section of the discharge on the hydrograph. Question 3. What sort of shape hydrograph is more likely to flood? Well, a hydrograph with a smaller lag time and a higher peak discharge is likely to flood. If I just sketch what that might look like, it would be like this. So 2 hydrographs, the same amount of rainfall in each, and this one has got a short lag time and a higher peak. This one has got a longer lag time and therefore a lower peak. I think that's pretty much it for flood hydrographs.